Hello student, this is OMPRAKASH YADAV. In the series of gear now, today I am going to start what is path of contact, contact length. So, path of contact, today I am going to understand actually what is the path of contact and how to derive the path of contact or contact length. For this I am going to refer this figure. From here we will be able to understand what is path of contact and we will be able to derive what is the path of contact. Okay, first let us see what is this figure. Now I have taken here, this is the gear and at the bottom this is the pinion. This gear is rotating about the center O2 with an angular velocity omega z, and this is the pinion which is rotating about the center O1 with the angular velocity omega p. With the angular velocity omega p. Generally pinion is the driver. Generally pinion is the driver and the gear are the driven. So I am going to demonstrate for that only, but the same will be applicable for all. Okay, so this is the gear, this is the pinion, this is the base circle of the gear, this is the pitch circle of the gear, and this is the addendum circle of the gear. Similarly for the pinion, this is the base circle, this is the pitch circle, and this is the addendum circle. Addendum circle. Okay, let us take pitch circle radius of the gear is capital R and addendum circle radius of the gear is capital RA. So from here to here this distance will be addendum height. If you add addendum height to this pitch circle radius of gear, you will get addendum circle radius of gear. Similarly, this is the pitch circle radius of pinion. This is the addendum radius of pinion. Now, to get the addendum radius of pinion, what you can do that this will be the addendum height. So, when you add addendum height into this pitch circle radius of pinion R, then you will get addendum radius for the pinion. Okay, look at here. Look at about this point. Here this pitch circle of the gear and the pitch circle of the pinion are touching. So this is the common point in both the pitch circle of gear and the pinion, and that is known as the pitch point. So this is the pitch point P. Now this is the common tangent at the pitch point. This TT is the common tangent at the pitch point, and this is the common normal. This is the common normal at the point of contact. Common normal at the point of contact. And from the previous lecture, you know that this common normal at the point of contact also is also the common tangent to the base circle. This common normal at the point of contact is also common tangent to the base circle. So base circle of gear is this one, base circle of pinion is that. So you can see here that this is also common tangent to the base circle, and that tangent point is N, and for the pinion this is M. Okay, now you join this O2M and you join this O1M. O1M. Okay, now let us see what is the start of engagement, what is the end of engagement, so that we can say that the point of contact has traveled how much distance. To see this, let us come on. So first contact will start from this. So tooth of the pinion will make first contact with the tip of the gear. The tip of the gear will be at the addendum of gear. So start of the engagement will start from here at the point K. So this point K is the start of engagement. So this will be when the pinion is driver. When the pinion is driver, they start rotating. So engagement is start from this point K. Engagement is start from this point K. Then the point of contact Q will be here. When the pinion will rotate, then the point of Q will travel along the common normal at the point of contact as the gear. So engagement height is started from here. Now the pinion is rotating. So point of contact Q will travel from here. They will travel, and that will go up to this point where the addendum of pinion is cutting this common normal. So this L is the end of engagement. So this K is the start of engagement, L is the end of engagement, and already I know that point of contact move along the common normal at the point of contact. Common normal at the point of contact. Now we will be able to define actually what is the path of contact. So what is the path of contact? It is the distance traveled by point of contact from the start of engagement, to the end of engagement. So what is the path of contact? It is the distance traveled by point of contact from the start of engagement K to the end of engagement L along the common normal at the point of contact. So this KL is the path of contact or contact length. So this distance KL is the path of contact or contact length. Okay. Now this path of approach can be divided into two parts. So this path of contact can be divided into two parts. Let us see. The first one from this K to P up to the pitch point, that is KP. So this KL is the path of contact. This can be divided into two parts. This KP into PL. So this is KP and this is what? PL. This distance from start of engagement to the pitch point is known as the path of approach. Kya? Path of approach. So this KP is the path of approach. And the distance from pitch point to the end of engagement, that is PL, is known as the path of recess. So this PL is the path of recess. So path of contact can be divided into two parts, that is KP and the PL. KP is the path of approach and this PL is the path of recess. Again you can see from here, again let us clarify. So distance from start of engagement to the end of engagement along the common normal, this one is known as the path of contact, and this path of contact can be divided into two parts. So distance from start of engagement to the pitch point along the common normal is known as the path of approach, and the distance from pitch point to the end of engagement along the common normal is known as the path of recess. When you add this both path of approach and the path of recess, you will get the path of contact. Okay, now let us derive it. Now I am going to derive. Before deriving, let us join this first. Join this O2K and join this O1L. Okay, let us see that radius of the gear, pitch circle radius of the gear is capital R. So from here, this is capital R. So from here, this is capital R. Okay, this is capital R. Let us understand one thing more first. So what is the pressure angle phi? It is the angle between the common tangent at the pitch point and the common normal at the point of contact. So this is the pressure angle phi. So what is pressure angle phi? Angle between the common tangent at the pitch point and the common normal at the point of contact. If this angle is phi, so look at here, this and this are at 90 degree. If this is phi, then this one will be 90 degree minus phi. This is 90 degree, so this will be phi. Similarly, if this angle is phi, this angle will be phi, so this will be 90 minus phi. Here is 90, so that will be phi. So if this is the pressure angle phi, this angle will be phi and this angle will be phi. Okay, now let us derive the path of contact. So in the triangle O2KN, what you are looking at, O2K square is equal to O2N square plus KN square. O2K square is equal to O2N square plus this KN square. So from here we can write this KN is equal to this under root O2K square minus, so this O2K square minus O2N square. So this Kn is square, so Kn will be under root O2K square minus O2N square. Look at here, what is this Kn? This is the Kn. So this Kn can be written as Kp plus Pn. What we can write this as a this Kp plus Pn. So Kp plus Pn is equal to this one. Okay, so what will be Kp is equal to this one minus Pn, this one minus Pn. So I am writing same thing here. So you are getting this Kp is equal to this minus Pn. This minus Pn. Just I am arranging. Pn will be here. That Kn can be written as Kp plus Pn. Pn has gone here. So that will be minus. Let us put the value of this all. So what we are getting the value of Kp. So this Kp is equal to under root O2K. Look at here, what is O2K? So this is O2, this is K. This is what the addendum circle of gear, and addendum circle radius of gear is capital Ra. So this is a capital Ra square minus O2N. Look at here, what is this O2N? Let us see here, this is capital R, so this will be capital R. If this is capital R, that can be resolved into two components because this angle is phi. So what will be O2N? This R cos phi. I have written here. So what is this O2N? This is R cos phi. What will be Pn? R sin phi. R sin phi. I have written here Pn is equal to R sin phi. Let us put the value of O2N. O2N is R cos phi. So this R square cos square phi minus Pn. Look at here, what is this Pn? R sin phi. So this is the R sin phi. Look at here, what is this Kp? This Kp is the path of approach. Kp is the path of approach. So I have derived the expression for the path of approach. Now let us derive the expression for path of recess. Now you take the triangle O1ML. In the right triangle O1ML. O1ML. So this O1L square is equal to ML square plus O1L square plus this O1L square. Look at here. This O1L in this triangle O1LM. O1L square is equal to O1M square plus ML square. So something I have written here. So this ML is equal to, so we are getting this ML is equal to under root this O1L square minus O1. Sorry, something mistake. So this O1L square is equal to O1M square. This will be O1M square. O1M square. So this ML square is equal to O1L square minus O1M square. And this ML can be written as MP plus PL. This can be written as what? MP plus PL. You take this MP on that side. So what you will get? ML. So MP plus PL. So you write here PL and the MP you write here. So that will be minus MP. So here is what? MP plus PL. MP plus. This PL can be written as this MP plus PL. Now I am taking this MP on this side. So I am getting PL is equal to this. Now let us put the value of all. Look at here. This is the P circle radius of pinion. So this is what is small r. So this O1P is small r. This angle is phi. So this can be resolved into two components. So this one O1M will be what? Small r cos phi. O1M is a small r cos phi. And this MP will be this small. If this is cos, then this is will side. So that will be small r sin phi. I have written MP is equal to small r sin phi. Let us put all the value. So this PL is equal to O1L chi square. So look at here. What is this O1L? This is the addendum circle radius of the pinion. So this under root this RA square minus O1M square, and this O1M is a small r cos phi. So this is a small r square and the cos square phi minus MP. Look at here, this MP is a small r sin phi. So this is what the small r sin phi. What is this PL? Look at here. This PL is the path of races. This PL is the path of races. So I have derived expression for what here? Look at, this is the path of approach and this is the path of races. By adding these two, you can get what is the expression for path of contact. So you can write the expression for path of contact as, so path of contact, this KL is equal to path of contact, KL is equal to path of approach, this KP plus path of races PL. So path of approach can be written from here and the path of races can be written from here. You add this both, then you will get expression for path of contact KL. So you are getting this KL is equal to under root capital RA square minus capital R square cos square phi minus capital R sin phi. So this is what the path of approach plus path of races you write here. So this under root capital small r square minus small r square, this cos square phi minus small r, this sin phi. So path of contact KL is equal to this path of approach plus this path of races. So if someone is asking what is the path of approach, only you calculate this one. If someone is asking what is the path of races, you can calculate from here only. Only you take this term. If someone is saying that calculate complete path of contact, then you take this both the term, that is path of approach plus path of races. Okay. So this is the general condition. So involute gear, now let us, I am going to see some special condition. Look at here. When the interference is just divided, then what is the path of approach and what is the path of races and what is the path of contact? So condition is that when interference is just divided, then this point, then this start of engagement K will be at the point of M. This point M and N is the point of interference. If the point of contact is in between this point M and N, there will be no interference in the involute gear. If the point of contact will go beyond this point, then there will be the interference in the involute gear. So to avoid the interference in involute gearing, the point of contact should be in between M and N. This point M and N is known as the point of interference. So to just avoid the interference, this start of engagement can be here. When you are increasing the addendum circle radius of this gear, then you are increasing for the pinion. So this point can go up to the point M. Then the path of approach will be MP. Then the path of approach will be MP. Path of approach will be MP. Look at here, what is MP? This is small r sin phi. So this is small r sin phi. Then this end of engagement point L will be at the point N. Then this Pn will be the path of races. Pn will be the path of races. So path of races is equal to what? This Pn. Path of races is Pn. Already I have written here what is the value of Pn? Capital R sin phi. So this is capital R sin phi. So what will be path of contact? So path of contact will be M, N. That will be Mn. So this Mn is equal to Mp plus Pn. This Mp is the path of approach and the Pn is the path of races. I have written here. So path of contact This mn is equal to mp plus pn. So this is small r sine phi plus capital R sine phi, or we can write small r plus capital R, this sine phi. So this is the path of contact when interference is just avoided. When the interference is just avoided. Okay, this is for the general condition, and this is in special condition when the interference is just avoided. Okay, thank you very much.